Welcome back to my Git course. We left in the latest episode having merged one bug fix branch onto another bug fix branch. So the idea is we created a couple of branches, and each branch had a commit, and then I've closed with merge strategy those branches onto the master branch. So the first one and the second one. And the result is when you close the second branch, you got a new commit that's the merge commit. So just a recap, two branches, each branch has only one commit, but when you close both branches on master, you end with three commit. First branch closed with fast forward, and second branch closed, creating a merge commit. Now, let's see the situation in a command line, and it's really clear. I want to show how easy it's working with Git and redoing work. Let's suppose I'm not satisfied with the result of this merge, and let's suppose I want to merge again. So I can simply say, okay, I'm on master, and master point to a commit that is the merge commit. I can issue the command git reset --hard and tell the master to come back to this commit. That was the commit of the first branch closed. And now here is the situation. So I have practically lost the fixed 777 commit. So now don't panic. As a recap, you were in this situation. You take master, you issue the reset hard command that's bring back master pointing to this commit, and this other commit and that other commit are not anymore reachable from this commit. So now the history is this one. So you can think, oh my God, I've lost those two commits. That's not true. If you look at this simple tool, I had added a visualize deleted command, and that's allow me to show deleted commit. Okay, here you are. These are the two commits you had before resetting the branch. So what happened behind the scene, if you understood what I've told you in the very first couple of modules, whenever you made a commit, Git creates a nice file pointing to the whole structure of the directory. It's like having a zip file of the whole content of the directory. Having this knowledge in your mind, you know that a branch like master is only a file that points to another commit. So the previous commits were not deleted. They are simply unreachable. So they are still in the Git repository. And if you issue a new Git reset --hard pointing master on this other commit, you can recover all of your work without any problem. Doing this in command line is much more easier because you have one nice command. It's a lifesaver command, Git Reflog. It actually tells you all the history of this repository. So whenever you move, whenever you check out a branch, whenever you change the head, this command lists you where the head was before you before reaching the actual situation. So actually, as you can see, I've done a lot of examples on this Git repository. But actually, the last command I've did is resetting the master branch to bd5e blah 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 blah. And before issuing this command, I was on that commit. So this corresponds to the same visual clue we have on the Git vids, but it is much more easier going on the reflog, because if you issue a bad command and you feel lost, you just move back and try to understand what's happened. And if you continue, you see that you have the whole history. So that's nice history you can follow. So that's the head at 1 is the previous position. Okay, you can copy and you can even use this to reset and come back to the previous position. So you issued a git reset --r command and you made a mistake because you say, oh, I've lost a lot of commits. You can issue another git reset --r, and then you can come back one in the history. So reset, this command is like, hey Git, I've done a mistake. So before resetting hard my master branch, I was in the real position. So please reset again. And here you are. You come back to the original situation, and GetViz is gonna testify that you indeed are in the previous situation. That gives me the idea of telling you that working with Git is extremely secure. Each time you made a commit, each time you create a commit, you're actually creating a zipped version of the content of the directory. So you are creating a zipped version of your source code. And that zipped version had a name, it's a file with a name, and the name represents the content. So there is no way you can override that content, that file, with different content. So that's the power of Git. So you can issue a git reset, you can issue whatever command you are thinking you're going to throw at the command line or the graphical user interface. Once you create a commit and the commit has the ID cdfd4bf, you cannot override that commit, never, because to override the commit, you need to recreate a situation where you have the same exact content of the folder and the same timestamp. This is a powerful giveaway. And this is a condition, this is a characteristic that other source control does not have. Git gives you the incredible security of working with your code because each time you create a commit, you cannot lose it. That's a thing, that's a concept that should be stuck in your mind. And this gives you great confidence in exploring different way on closing your branch, on working with your source code, because you know that you can experiment with whatever command you can find on the internet or whatever strange command you can throw at the command line. And if you keep track of where you were before starting a great refactoring of your code, you can always say, okay, that refactoring was wrong. I'm in the middle of something. I get lost. Git reset --r and the ID of the commit of the stable situation. And in an instant, you're back to that point in time. Now we're moving to the real part of this episode. So I want to show you a different way to use to close your branches. Now, let's suppose you close your fixed 777, your bug 777 branches with a merge strategy. So you've created an history that is not linear. So the history is not linear. As you can see in the history, there is track that I've developing something in parallel. So at a certain moment, the history diverged and what reconciled with the master branch. This is not bad per se, but it can complicate history. So it is much more better to find another strategy of closing the branches. And the first thing is I need to come back to the situation I were before the merge. How can I do this? Oh, it's really simple. First of all, recreate the branch bugfix 777 to the real content where it was before merging. So it is Git Branch. To create a branch, I call the branch bugfix 777, and instead of pressing enter, and that will create a branch on the current commit, I simply tell Git, hey, open a branch on that commit. Okay, now I have a nice bugfix 777 branch before closing the branch with merge strategy. Now I'm on the master branch. I need to close the master and I need to reset the master to the position it was before the branch were closed with merge strategy. So I'm in the master branch, and I can issue git reset hard, and you know the game. Okay, now I'm back to the situation where I have the master in one commit, my branch bug fix in another commit, and I want to close that branch. My Git vids show clearly that I already had done this before, but actually this commit is deleted. So I can stop visualize deleted command, and that's the situation. How can I keep the history linear? Well, it's simple, because you first need to understand that when two branches diverged, you have one commit that is the commit, the first common commit those two branches had. So that's important. Given this information, I can simply take all the commits that are on the branch I'm gonna close and just take each commit, take the diff of each commit. So each commit contains an increment, a differential with the previous commit, and just replay on top on my destination branch. So that's an operation that Git is gonna do for you. And it has command for doing this, and it's called Rebase. Basically, Rebase tells if you want to keep your history linear, you have one bunch of commits in a branch that you need to close on another branch, but you don't have fast forward because the other branch has commit that are not in the branch you are going to close. So you just find the common commit and replay all the commits on the top of other branches. Well, it's more easier to done than to explain, because the command is git rebase master. Git rebase master actually is telling Git to rebase the current branch on the master. But first of all, I need to move on the correct branch. So remember, before doing a rebase, the general rule is you move on the branch you want to rebase, and then now I am in the bugfix 777 branch, and that's guaranteed by the fact that the head pointer is pointing to the bugfix 777 branch. I can issue git rebase master. Okay, since I have no conflict, because it's the same code as before, so I have no conflict, Git does not break telling me that I need to resolve anything. But I now can issue a git log f and look at now the situation. The bugfix 777 has the commit fixed 777 replayed on top on the master commit. As you can see now, the commit is C878C9A, and it's not the same of 8802 blah blah blah. So that's normal, because you have actually recreated another commit. To have this much more clear, you can look at git vids. That will explain a lot better what's happening. So that's the previous location of the bugfix 777 branches. That is the merge commit I've done before. Now, when I pointed the branch bugfix 777 onto commit 8802, the original commit, and I tell Git to git rebase master, it found the common commit, this one, then take each commit of the branch, this one, and then just replayed on the master branch, and clearly all the modification replayed on top on another commit will result in a different commit. And it is normal because commit has a timestamp inside the header file, the head part of the commit file. So each time you recreate a commit, it cannot be the same as before because the timestamp is changed. But this simple example shows you how easy it is to keep your history linear. But this is not enough. After you rebase your bugfix branch, your branch onto the master, onto the main branch, you see you still have two branches. Now, when I closed with merge, I have a single new commit where everything is okay. Now it's a little bit different. My bugfix 777 branch, it's still different from master, but now after the rebase, I have a linear path that brings my master to the bugfix 777 branch. So now I can simply do a fast forward of my master branch on a bugfix 777 branch. So what I can do is remove on master branch, this is the situation. Now, if I want to close my bugfix 777 branch, I can simply git merge bugfix 777. And, even if I'm issuing a merge, if you remember the latest episode, master has a direct line to bugfix 777. So I'm on master. I'm asking Git to merge with this branch. I have a linear fast forward path that going from master to bugfix. So fast forward. Here is my history. Now, master and bugfix 777 points to the very same commit. So bugfix 777 was clearly closed. I can simply delete the bugfix 777 branch. And here's the situation. So in the situation, I have a branch that contains this only commit, and the master branch was in the red commit. Okay, if you issue a merge, you create a third commit that contains the modification of both branches that diverged. But this will create a non-linear history. So you see, at a certain point, the history was not linear, was diverged. If you want to keep your history linear, instead of creating a merge commit, you can move on the branch you want to close, issue the git rebase command, git rebase, and specify the master branch or the branch you want to close your branch in. So you got on the branch you want to close, and you git rebase on the destination branch. This with actually replaying the commit, creating a series, one commit for each commit of the original branch. So now I have a branch with only one commit, and I'm expecting after the rebase to have one single commit difference. But this time, the commit will be replayed on top on the destination branch, so you can move on the destination branch master, and then finally issue a git merge that will result in a fast forward. Whenever you have a feature branch, a short-lived branch, you move on that branch, you git rebase stable branch, you git checkout stable branch, and you git merge feature branch. After that, you can git branch delete feature branch, and everything is closed. Thanks for watching, and I hope you enjoyed, and let's see you again on the next episode.